Welcome, viewers, to another exciting episode of the It Depends podcast. This time, we are tackling a super critical way by which we are accessing a lot of websites, a lot of applications, and that concept is the concept of hybrid search, where we're doing a search and it could be a combination of lexical search and vector search. I am honored to have Carl Meadows join me this week. I met Carl. Actually, we've known each other for a few years over the phone, but we met in person a few weeks ago. I attended a conference called OpenSearch Con in San Jose, California. Carl is the chair of the governing board of OpenSearch uh, Project Foundation, which is part of Linux Foundation as of 1 year ago. He's also director of product and design at AWS. Carl, thank you so much for taking the time and coming to this podcast.
Oh, thanks for having me. It's my pleasure.
We have spoken for many years, but some of our viewers may not know about you, your background. So before we get into OpenSearch, I did a very high-level introduction, but can you please do justice to what you do?
Sure. Yeah. As you mentioned, I do chair the OpenSearch Software Foundation, which is a body of members that are provide financial support to the OpenSearch project, which is
Mhm.
independent from like the technical steering committee, which makes the technical decisions about the direction of the project. Um, I also, in my day job, am a director at AWS, and amongst the things I oversee is the Amazon OpenSearch service. I've been with AWS 10 years now, and I've been working in this space since I joined. Yeah.
Very nice. So with
Yeah.
that, let's get started. Thank you so much for that introduction. The first question on my mind is, what is OpenSearch and how did it come about?
Sure. Yeah, the OpenSearch started as a fork of Elasticsearch after Elastic made a licensing change in 2021. So Elasticsearch had historically been an Apache license that was open source and highly permissible and allowed uh, anyone in the community large latitude for like what they did and how they consumed and used the project. Elastic changed the license to be more restrictive. And at that point, AWS led a fork called OpenSearch um, to preserve that permissive license and to build a robust open source community around OpenSearch. Um, I'm delighted since that time in 2021, the community has grown. We've had lots of additional folks get involved and want to take more and more active part in developing and leading OpenSearch forward. And as part of that, last year, AWS transitioned OpenSearch to the Linux Foundation to provide a truly vendor-neutral governance and to allow the community to expand. Um, since OpenSearch joined the LF, has been great in the last year. We've had over 8,000 contributions from over 3,000 different contributors across over 400 organizations. And apart from that breadth, many of the largest companies in tech have begun getting behind the project and supporting the project, including folks like Uber, SAP, IBM, DataStax, NetApp Instacluster, Atlassian, ByteDance, DTEX, and many more. So really excited to see, AWS working hand in hand within this large community to really drive OpenSearch forward. It's been great.
One of the super interesting keynotes I attended at the conference was from NVIDIA, how they are porting open source to run on GPUs. And they've created this whole library on top of CUDA called QVS. And so that's another very interesting development I saw from them. And then SAP talked about migrating. I think they run OpenSearch on 11,000 clusters, which I found fascinating. So,
Absolutely. Yeah.
so Carl, how do you strike a balance in the open source community between protecting community-driven values and enabling monetization partnership that sustain the project?
Yeah. So In the I think businesses invest in open source technologies
Mhm.
because it's really in their interest to do so. They see huge value in being part of broad communities with
Hmm.
fast innovation, being able to reduce the maintenance burden of having to build and sustain these technologies on their own, or in other cases where they would pay another commercial company to do that work for them. So in a lot of cases, open source can be, a great decision for businesses. Now, every business that, starts building on an open search, stack makes their own choices about like what parts of their innovation are broadly beneficial to the community and what parts are like really specific to their business needs or critical to their own differentiation. And that's really on each company to
Hmm.
decide. Um, the I think as long as, in general, as everyone's clear and transparent in those conversations, it's not that there's never any tension, but the community, can work together and go forward as long as people's general business interests are aligned and they're making the right decisions. The It's really the maintainers that are working in the technical part of the community that are reviewing requests for comments or reviewing individual PRs that are reviewing those to make sure that they are implemented in a way that's broadly beneficial and not narrowly
Hmm.
beneficial. And that's often a lot of the give and take that occurs in a GitHub. Individual issue is that a maintainer might be like, okay, I see how this implementation would work for you, but if you made this one tweak, more people could use it. It would be more broadly beneficial, or it would deconflict it with these other feature requests we're seeing. And that's just part of the open collaborative process that occurs naturally in well-run open source communities, in my opinion. Yeah. Mhm.
Well, I've seen in the past there are, I won't name these open source projects, but they are open source controlled by just one company. So all the commits are just made by a handful of people. You've got uh, over 3,000 contributors last year.
Yeah.
So I'm curious, who are the maintainers? Which companies do they come from? How do they handle when there's such a huge influx of change requests that are coming in? And what happens in cases where there is a clash? One request may contradict somebody else's request. So does that happen? And then how's the whole life cycle of requests handled?
Sure. That's a great question. You know, it helps to understand like OpenSearch isn't one thing. I forget the total number of repos now, but it's well over 100. I think it's over 130 repos make up OpenSearch. And uh, it's best in these communities when the decisions are pushed closest down to the people that are most familiar with the issues. And in this case, each of those repos has maintainers. And those maintainers are um, will review and approve or suggest changes for each individual, contribution request that's coming in. And I would say the vast majority of issues get resolved directly by the maintainers um, that are working on that particular issue, that have a good understanding of the scope of other things that are in the pipe or coming, or understand, they're the closest to the problem.
Mhm.
Um, OpenSearch itself, though, does have a technical steering committee, which is a technical body that's elected from those maintainers from across
Mhm.
multiple companies that generally are involved in more higher level decision making, but are always available to help if there's a situation where they need some additional assistance to deconflate issues or things like that. Um, uh, yeah. So that's where things would escalate to if there was like a problem that wasn't getting resolved.
So when these requests come in and they get implemented, how do you handle some features getting commercialized, but some set aside for community access? And I'm asking this because many years ago, when I was an analyst at Gartner, I used to field a lot of inquiries from Elasticsearch customers. They were they loved the technology. They were very enthusiastic about using it, except there was no security in the open source version.
Yeah.
And I remember that I used to maintain a list of about half a dozen or more community-driven projects on GitHub that added authorization and all kinds of security because the official answer from Elasticsearch was, oh, now you have to buy commercial version.
Yeah. So yeah, and I think that that's typically one of the risks around vendor-controlled open source projects,
Hmm.
because then the interests of that vendor, can not always be aligned with the community. They can sometimes be more aligned with the business interests of the vendor. And it was one of the really important reasons why we wanted to transition OpenSearch from being vendor controlled, which it was when it was AWS. Even though we had a broad community of folks, ultimately vendor AWS owned those GitHub repos. So when we transitioned it to Linux Foundation, AWS no longer owns these GitHub
Hmm.
repos. We couldn't change the license if we want to. And it's a Linux Foundation project now. So there is no one vendor that can bias this project towards their own economic interests. So that's one of the great things about vendor neutral projects where you don't have that conflict that's inherent in a vendor controlled project.
So AWS had an open distro, right,
Yeah.
of OpenSearch. So, if we go take a step back from OpenSearch, every hyperscaler has some sort of fully managed search service that includes both hybrid, so it includes normal search and AI search. Why would an organization want to adopt OpenSearch over the convenience of a fully managed search? So how do you convince when like companies come to you and they're evaluating, how do they make that decision?
Well, uh, wearing my AWS hat, I don't think that's a trade-off you should have to make. I think you should be
Mhm.
able to use an open source technology and get that convenience and the turnkey solution from your cloud
Mhm.
provider, which is what I've strived to do with AWS, Amazon Open Search Service. But it's uh, it's really about choice, and I think there a lot of customers like building on open source because it removes vendor lock-in. They
Mhm.
know if that cloud vendor is a vendor, and if for whatever reason they want to move that workload somewhere else, or they're not happy with the service they're getting from that vendor, if it's an open source based technology, they're not locked in. They always have the option to be like, I can just go manage it myself. Or if I want to move this on-prem, I can move it on-prem. Or if I want to move it to a
Mhm.
different cloud, I can move it to a different cloud. So that lack of lock-in
Mhm.
is really valuable. So, that's why we do see OpenSearch being made available in multiple clouds. Like I said, AWS offers it, Oracle offers an OpenSearch service. Are some of the partners in the OpenSearch community, such as NetApp, offers OpenSearch across multiple clouds,
Mhm.
as does Ivan. Um, DigitalOcean has an OpenSearch service. So I think you can have the best of both worlds myself, where you provide an open source based technology that's still really easy to use and turnkey, like you said. It shouldn't have to be a choice. Yeah.
And how does OpenSearch compare to more proprietary solutions in the past? And I know this is no longer true, but I'd like your view. There was this criticism that open source projects sometimes lag behind proprietary solutions. Uh, I don't believe in it, but I'm just curious about your thoughts on what you see.
I certainly think OpenSearch is extremely competitive as a
Hmm.
search platform when it comes to price, performance, scale, the types of functions and features it enables. Um, I, commercial products often do have an advantage around being more opinionated about an end-to-end
Hmm.
experience. Um, uh, Whereas OpenSearch is more of a platform that builders can implement in lots of different ways. Many commercial platforms are actually built using OpenSearch underneath it, for example. So I do think that tends to be a trade-off with open platforms versus commercial platforms is more, it tends to be less opinionated. It tends to be more focused on builders. Um, though, I think the bar is always rising to try to make that end-to-end experience better and easier for people.
Got it.
Yeah,
So let's change tracks here. Let's talk about OpenSearch, the product itself.
sure.
What are the uses? Why do people use OpenSearch? What are the major use cases?
So, you know, I often will kind of equate OpenSearch to a Swiss Army knife, but because it's really useful in a lot of use cases.
Hmm.
But at its heart, it's a information retrieval system or a search engine, and um, it supports a number of different techniques for providing information retrieval and non-structured data. Um, the there is a lot happening right now with search more broadly as AI and models are able to much better understand language than, traditional lexical or keyword search. Um, that's enabling uh, a lot of companies to relook at how they provide these experiences in their own platforms and applications. And OpenSearch is at the center of a lot of those discussions. So the whole information retrieval, vector databases, semantic search, traditional search is all about providing highly relevant data from loosely structured or unstructured data sets, be it text files, be it video files, it could be anything. But being able to provide that retrieval system and make sense of that data is really what OpenSearch excels at in the search domain. On the other side of the equation is more analytical use cases where OpenSearch is also popular. These tend to be more time series style use cases where um, can be observability or any sort of telemetry data or security data. And what makes OpenSearch really powerful in those cases is those data streams can often mutate a lot. New
Hmm.
logs can come in, there can be new fields added, and so OpenSearch really gracefully handles unstructured data and can just index this data even as it changes. I don't have to have a rigid pipeline and rigid schema to use OpenSearch. And then I also don't have to know what I'm looking for. So in security and observability contexts, you often don't know before a problem happened what you needed to find. So that's where the information retrieval and rich aggregations and analytical capabilities become super beneficial, so that uh, when something does come up and you need to go and like uh, try to parse a heap dump or just a rich set of flow logs for specific conditions, you don't have to know in advance that you needed to do that. And OpenSearch will have the data and you can quickly find that information. So it makes it really useful for, analyzing large streams of telemetry data for security and observability use cases.
So observability, log management,
Yep.
anomaly detection. So
Yep.
these are all,
Yep.
and
Yeah.
I saw at the conference that OpenSearch has a very tight integration into standards like OpenTelemetry.
Correct. Yeah, increasingly folks are adopting OpenTelemetry as a standard for their
Hmm.
observability schemas because it makes it that much easier to correlate and find information if you understand the schema and how they relate across the different systems. And so OpenSearch has brought support for OpenTelemetry for those use cases. Yeah.
Going back to this keynote that I attended, where SAP was talking about how they had Elasticsearch managing their logs, massive amount of logs that get generated, and then they moved to OpenSearch when the license change happened because they wanted more voice, they wanted their own requirements to be added to the product. So the question that came to my mind listening to them, and maybe you can help demystify this, is how does one migrate from Elasticsearch? I know this, we're not like delving on Elasticsearch here,
Yeah.
but what are the challenges? How easy or difficult would it be for an organization?
Uh, for uh, yeah, I won't go into tons of detail, but for someone like SAP, they were running legacy versions of Elasticsearch prior to the fork. So
Hmm.
it's actually a pretty seamless upgrade to go from those versions to OpenSearch because OpenSearch is forward in the versions from where they were. For a customer that's like, say, on a more modern version of Elasticsearch post fork, then you might have to do a little bit more work to migrate. But you could really upgrade if I was SAP without actually having to migrate. Now, we've also built in the community has an OpenSearch assistant, which is a set of tools
Hmm.
that allow you to do things like uh, move data as well as to write, load balance between two environments and do a smooth cutover between your environments. So you can do testing and run the environments in parallel and help assist with production migrations where you don't want to take downtime. It has a set of tools that the community have developed to help. Um, yeah, that's the migration assistant, which is one of those hundred plus repos in the OpenSearch project. It's definitely recommend people take a look at it.
I
Yeah.
see.
Yeah.
Carl, drawing some parallels here based on my previous experience with databases, MySQL was an extremely popular open source database, and then Sun Microsystems bought it, which then got bought by Oracle. So the founder of MySQL, Max created MariaDB, which originally was wire compatible. So any application of MySQL would just work directly on MariaDB. But then as MariaDB developed, it started moving away from the code base. And then they said, no, 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 sorry, we are no longer wire compatible. Because it took a life of its own. I'm just wondering, how did it happen with OpenSearch? Was it originally wire compatible to Elasticsearch and now it's not, based on what you just said?
Yes. So the OpenSearch 1.x is wire compatible with Elasticsearch 7.10, which is where the fork happened. Um,
Okay.
uh, the Elastic also had some proprietary APIs that were not part of the open source, which are not compatible with.
Hmm.
Um, uh, the not, I'm trying to, sorry, I'm thinking on the fly. I'm not aware of any significant breaking changes in the core
Hmm.
APIs, even up through 3.x. There's minor changes, like both these systems are built on top of Apache Lucene. So the actual storage format um, uh, evolves forward. So you actually have to reindex your data, which you can't just run an Elasticsearch 7.x index on an OpenSearch 3.x environment. You actually have to reindex and upgrade your storage as you go, but the breaking changes are pretty minimal in the core APIs.
I
And
see.
nobody likes breaking changes. We try to avoid them as much as humanly possible.
Yeah.
No,
Yes, we don't like breaking.
yeah,
By
yeah.
the way, since you mentioned Lucene, I was good friends with Duck Cutting. Many, many years ago, he's completely vanished from tech scene. He was at Cloudera at that time. He would come to Gartner conferences as my guest. He created Hadoop, which
Mhm.
he named after this stuffed toy elephant he had for his kid. He also created Lucene, which he named after his wife's grandmother. So that just a bit of history that I just got reminded of when you said Lucene. So Lucene still is,
That's some long impact. Yeah, that's some, yeah. Yeah.
yeah, it's quite a
Yeah.
bit of history there. So moving to changes, not breaking changes, but new additions that have been added into OpenSearch since it forked off and it has now been developed. So you're at version 3.2, correct? At this point?
Yep.
And vector search has been added. Can you talk more about like more about vector search and what are some of the underpinnings of the technology for vector search?
Yes. So, one of those use cases in the search space is OpenSearch is very popular as a vector database or vector backend for AI systems. Um, the OpenSearch is actually one of the more mature technologies in this space. The the vector engine actually goes back to 2019, when we originally packaged it as part of a KNN plugin that was part of what was
Hmm.
Open Distro for Elasticsearch, which was the set of open source plugins for Elasticsearch that was a precursor to OpenSearch. Um, and at AWS, we actually drove a lot of that KNN work to support a lot of our own internal AI workloads.
Hmm.
A lot of them needed a vector or a KNN backend to support these models, have an embedding interface for these models to power experiences across Amazon and AWS. So, we built that to help service those customers, and then we made it available to all the rest of AWS customers via and of the open source community via this distribution. But that engine has evolved, and very rapidly from 2019 as these models evolved and as the vector techniques have evolved and new algorithms have come to be, new compression techniques, new tuning techniques, memory versus disk combinations to support a full range of vector use cases, from cases where you need really high performance in memory, highly relevant data, to maybe you're willing to trade off on some latency and you're trade off on some recall to really drive your price down and compress those vector databases so you can support super high scale for, less than the GDP of a small European country. So, OpenSearch is really flexible and has a lot of techniques available for builders to really leverage it for their, to tune it for what their use cases are. And I think some of the largest, vector installations out there are using OpenSearch as a backend.
It reminds me of another interesting thing that's going on as we speak. As we record this, Amazon Prime Day is going on, which relies, so a lot of product searches, product catalogs, the whole thing is in DynamoDB, which is a key value data store. So a couple of years ago, AWS introduced Zero ETL, which is quite amazing because it keeps these different databases synchronized, like OLTP Aurora with Redshift, which is OLAP. But my favorite one is where you can take DynamoDB transactions, create vector embeddings, and then do semantic search in OpenSearch. So, is that one of the things that you get involved with?
Yeah, wearing my AWS hat for sure. Wearing my AWS hat, making it easy to, reduce a lot of the heavy lifting that builders have to do to like synchronize a vector database with with like Dynamo, for example.
Right.
Those are types of innovations that we'll provide to make it easy for customers. So yeah, but that's really more wearing my AWS hat because it's a lot of AWS service management that we're
Correct.
doing to make that
Correct.
happen. Yeah, yeah.
Yes.
Yeah.
So, Carl, how does OpenSearch help with some of these AI workloads like retrieval augmented generation or RAG? And I'm asking this because everybody has RAG. In
Yeah.
fact, my next question is going to be MCP server. Everyone has MCP server now. So
Yeah.
these are no longer uniquely differentiated, in my opinion. So I'm just curious, like, what makes OpenSearch a good database to do RAG uh, as an MCP server?
Mhm. Yeah, that's a really good question. Yeah, I uh, tend to agree with you. I mean, I don't think doing RAG or doing MCP are differentiating experiences. Like
Mhm.
um the being a good, a RAG is a whole category of types of interfaces, right? Like being a good backend for a RAG uh
Hmm.
really comes down to, how your recall, your cost, your performance, and then as well as being able to integrate, a lot of the other search capabilities into the RAG backend using, hybrid search or the other capabilities of OpenSearch, like geospatial filtering or fuzzy or autocomplete. All of those things are available
Hmm.
as part of OpenSearch. So it makes it really easy to have OpenSearch as a backend supporting a RAG use case without having to have multiple platforms or stitch together a lot of middleware. So like if I wanted to have a RAG that wanted to use geolocation, I could just build it on OpenSearch. I don't have to build two different systems. I don't have to have a geospatial system sitting in Postgres and the search system sitting in the vector sitting in OpenSearch and my lexical search somewhere else. I can just build all of that on OpenSearch. OpenSearch is great. I'm not having to build a bunch of complex middleware to stitch these solutions together. And then OpenSearch also provides the performance scale and economics such that makes it a good platform for a wide range of use cases. Um, so it's really more about the quality of the experience that OpenSearch can provide than the fact that it plugs into a RAG, because you can plug anything into a RAG. That doesn't necessarily mean it's going to provide a good experience to the end customer.
Yeah, in
Yeah.
fact, I've noticed like people are saying, "Oh, I can talk to my PDF documents because I can embed the PDF document and then I can just use in my prompt, it can go search the PDF document and then use an LLM to give me the response." But it doesn't work. It's people make it sound very easy, but a PDF document is a very complicated document. It's got tables. It's got like it's not like left to right. There are footnotes, there are captions, there are headings, and it's like how do you embed
Yeah.
parts of
Data,
that?
yeah, data extraction is one of the hardest parts of that problem, more than
Right.
the, yeah. In fact, though, on that example, one of my favorite examples, Adobe spoke at OpenSearchCon, uh, was it last year or the year before?
Hmm.
And they described how they were the Acrobat assistant,
Hmm.
uh, and every file, in Acrobat, if you go say ask questions, use the AI assistant, it's actually using OpenSearch as the backend for
Okay.
that.
Okay.
And the part I thought was really cool was that they don't index like all trillion PDF documents in the world. What they do is when you go say ask a question, it just in time then goes and creates embeddings for that PDF. And in the time it takes that chat to spin up, they've actually vectorized that data and attached the model to it, like built a little mini RAG on that document. That then you ask the questions, and then after a few hours, it just
Hmm.
tosses it and rebuilds it next time you ask. So that way they can like really economically support this massive, world of Acrobat users without having, to build like the world's largest RAG, because it's doing
Yes.
it all just in time, which is cool. Yeah, yeah,
Since we are geeking it out,
yeah,
I know you're very close to the whole embedding space, like dense versus sparse. Can you talk more about
yeah.
what happens in this space?
Yeah, so like I said, there's a lot of different techniques from
Hmm.
hybrid search, traditional lexical search, which is just keyword, and then there's both sparse and dense vectors. Um, the, why all these, techniques are ultimately valuable is, let's just take lexical first, and then we don't always know the types of questions our customers are going to ask.
Yeah.
So a customer may ask something extremely unambiguous. They may ask me like, "Hey, show me this new Air Jordan shoe." Like, I don't need to go ask an LLM what that Air Jordan shoe is. I know exactly what that Air Jordan shoe is, and I can show them the one that's on sale without having to go talk to any system. But then they might also ask something like on this extremely ambiguous is like, oh, I want a running shoe for old people that helps it with it's good with ankle support or something. Like, well, and no keyword search is probably going to give you something good for that. That's where the models really shine, because it can really parse that ambiguous information, search against an embeddings or dense embeddings in that case, probably, and come back with like really relevant results. So hybrid search is being able to combine both of those so that you can have one interface where the customer is asking both ambiguous and non-ambiguous questions, and the most relevant results always come to the top. Um, Sparse vectors, uh, I tend to like to describe more as an enrichment on a lexical search. So what sparse vectors, what you're really doing is you're taking what's going into the keyword search, you're running it through a model, And that model is adding semantic context to that lexical search, really. So that way, you don't have to write a synonym file with, 7 types of green, and 7 different
Yes, yeah,
synonyms for green. It's like building that semantic enrichment of that data, so your search is just more efficient out of the box, and you don't have to call a model at search time. Whereas a dense vector is where things are really ambiguous. The model can really parse the understanding and can provide back the results. So all of these techniques have value and they
I
can be
see.
all combined in OpenSearch. Yeah.
So basically, if you use sparse vectors, then you get faster response. But if you want more accurate, especially if it's ambiguous question, then you go with dense
Yeah.
vectors.
Sparse has been, like, we've seen really good results and just out of the box, just turning on Sparse. It's
Yeah,
pretty cheap and you get a really nice boost in relevance.
I see. Is BM25 an example of sparse?
BM25 is an algorithm used in lexical search.
Yes.
So yeah, yeah, yeah.
That is great. I have one more question, and then I want to change tracks and ask you about the roadmap.
Sure.
Where is OpenSearch deployed? Because you mentioned OpenSearch with NetApp, InstaCluster, Ivan, AWS, so you can move between different cloud providers. Is it containerized? Can I run it on an edge device for my IoT use cases where I'm getting logs?
Yeah, so OpenSearch, the software, is available through a number of distributions. The most popular of which is Docker. So, um, but there's RPMs, a number of distributions where you just deploy directly into Linux. But we provide a Docker distribution
Hmm.
um, where you can just take those containers and then run it anywhere your containers can run. And one of the popular repos or deployment mechanisms is to use the OpenSearch Kubernetes operator, which also supports Helm charts. And then it makes it really easy to run it in any type of, Kubernetes
Mhm.
environment. Really reduces the management burden for deploying and managing it in Kubernetes.
That's great.
Yeah.
I thank you so much for geeking it out. It's my favorite part of this podcast, and you're the best candidate to do it. So let's turn back into more strategic topics. Agents all over. In fact, OpenAI Dev Day is going on right now as we speak. And it's all about multi-agent. So, where does OpenSearch play in this agentic architecture we're going into?
It's going to be really fascinating. And I think it's, yeah, there's a lot of like pontificate about where it's
Hmm.
going to go. But I mean, regardless of like some of the architectures that emerge, um, the end of the day, there's more and more unstructured data being generated,
Hmm.
and being able to provide highly relevant results from these mountains of data, whether that consumer is an end user or if that consumer is an agent, or if the person producing those results is an agent. Um, uh, Agents have to be able to find and retrieve data. So, I think search is just going to keep evolving and becoming more and more relevant because there's just more data these things have to sift through. And um, I think the search volumes are going to go up, would be
Hmm.
my, agents and are much less likely to get tired than people. So
Yes, yeah,
a
yeah,
person might do 3, 4 searches and be like, good enough.
yes.
And an
Yeah.
agent's going to iterate and refine until it gets the information it wants. So
It,
we might see much higher volumes
I see.
in those systems. Yeah.
When Databricks bought Neon this summer, all of a sudden it opened a whole slew of ideas about what a database can do, because according to Neon, 80% of their database is brought up and shut down by agents.
Mhm.
So do you see OpenSearch moving in that space where it becomes sort of the memory store, if or context store
Yeah.
for agents?
Yeah, that's actually a space that we're seeing a lot of community interest in, and there's
I
been
see.
innovation is providing an integrated
Yeah.
memory, agentic memory as part of OpenSearch, which uh, provides a much richer set of contextual
Hmm.
understanding of previous conversations and also makes, again, reduces a bunch of middleware for you having to manage a separate system and page a bunch of data in and out of the system every time. Um, there's a follow-up question, say, that the agent's following up on. So yeah, agentic memories are really
Hmm.
there's a lot of folks contributing and interested in developing that. I believe the first version was available with 3.2, but it's there's a lot
I
going
see.
on.
Yeah, so Carl, what we saw this week at OpenAI Dev Day is actually very, it's a game-changing thing. What they're showing is that in ChatGPT, you can just start doing anything and everything you want, like from shopping to booking to your meeting, and ChatGPT is calling the underlying systems. In fact, a lot of these Ubers and DoorDash sort of disappear from the front end if ChatGPT is orchestrating all the user interactions. I'm just mentioning, it may have some impact on open search when suddenly ChatGPT becomes your point of contact with the entire online world. So,
Yeah,
yeah.
yeah, that'll be
Yeah.
yep.
So that takes me to the last question,
Sure.
which is what are your biggest goals for open search for the next 5 years?
So the you know number one, I want to see the open search community continue to thrive and diversify and have more and more folks contributing, um, uh, which will lead to greater innovation and a better, healthier product that the industry can really rally around, so that it can be a core platform that builders rely on and use to build all sorts of wonderful experiences. Um, the We've seen great progress in that in the first year in the LF, and so we're really excited to see that journey continue. Um, uh, because I think this is a really important foundational technology for builders, and it's going to become even more important in the days to come, where there's more autonomous searching going on, and there's more agents that are doing agent-to-agent communication, having um, a core search platform that folks can rely on, an information retrieval platform really that people can rely on, I think is going to be a very essential building block. Um, uh, and then, as when it comes to more of the technology, like the core engine capabilities, I don't think any data engine has ever lost because it was cheaper, faster, or more efficient. So, we've made great progress in improving the efficiency and performance of OpenSearch since the fork, and I'd love to continue to see that through as we, modernize the analytical engine under the covers and really make OpenSearch the fastest, most performant, most cost-efficient platform, but for both search and analytics. Um, so yeah, I'm really excited. I think we're well on our way on those journeys, and um, really
Yeah.
excited to see what the future holds.
Is there a time period for the chair of the governing board?
Uh, I think we should probably, I think we're going to align our vote probably around the calendar year. The So we're right at a year now, and I don't think we finalized that decision. I think
I
we're going to
see.
get the next governing board, but I think the thought is we'd probably align it around the calendar year and do our next vote there.
And you've been traveling quite a bit. I saw Open Search Con took place in 5 different places all over the world this year.
Yeah,
So, yeah. And
yeah.
next year it'll be even more. You're adding more locations, right?
Yep, we announced at OpenSearchCon North America that we're going to hold our first OpenSearchCon in China in March, in Shanghai. So that'll be fun. We had a lot of interest, and we have a lot of contributors in China. So it'd be great to have our first event there. Um, OpenSearch India has been hugely popular. We uh, we did our second OpenSearch Con India this year, and the user groups there are really exploding too. So um, this is one area where I've just been thrilled, having LF's backing because Linux Foundation is great at events. No, and
Yes.
they've been super helpful at us scaling these events and scaling the community, and it's been really great partnering with them.
Yeah,
Yeah.
Linux Foundation does an amazing job. I haven't missed any Linux KubeCon in many years in US and Europe. So I'll see you there in a
Yeah.
few weeks. So before we go,
Yeah.
bonus question.
Sure.
When I do these podcasts, I ask, tell me something about yourself that's not technical, that the world doesn't know about in general. What do you
Okay.
like to do?
Sure.
Hobbies? Yeah.
Um, well, the maybe the more surprising one. Um, my first career was as a music engineer in
Oh,
Nashville,
oh
making
wow.
albums as a studio recording engineer in Nashville in the 90s.
Oh wow.
So I worked there making albums, and then really loved music. My undergrad was from Berklee College of Music, and yeah, I love music. But uh, I came to the realization it maybe wasn't the best way to make a living in the in the late 90s, right as the .com and the internet was exploding, and was able to move into tech at that time. So that might be kind of surprising that I was actually
Hmm.
actually come from a music engineering and music production background and not a tech background.
Wow, very interesting. Can I have you come over and DJ a party at my place?
Yeah, for sure.
Okay, awesome. With that, Carl, it's been such a pleasure. Thank you so much. This has
Oh,
been such a great episode. I learned a lot, and I'm sure everyone will learn quite a
yeah.
bit. So I
Well,
really appreciate it.
thanks for
I,
having me. It was my pleasure. Yeah.
you're welcome. Thank you, everyone. Thanks for staying till the very end. Until next time, see you.